Can I get you all to stand up, please? I want your feet flat on the floor.
The aim of this session is to help students relate the forces they experience in everyday life with the more formal representation of forces they will encounter as part of mathematics. To begin, the teacher encourages them to explain the forces they feel in terms of their current understanding.
What did you notice?
More force on loaders on the floor.
Okay. The task I did with students was focused on not just to think about them, but to actually feel what those forces were. So looking at the actual physical impact. So we started off by standing on two legs, standing on one leg, having books between them so they could feel the forces there, so that they could then translate that physical impact into mathematical impact through pictures. Push it just ever so slightly and tell me what happens.
It goes for.
Okay, can you turn it over? And I'll do exactly the same.
Stopping.
Okay, so there's a reason for that. Can anybody tell me what that reason is?
There's probably like more grip on the other side, so there's increased friction.
This might have been the first lesson that they'd come across forces. They might have been aware of them in previous situations, but not necessarily looked at them in detail.
Having begun by thinking about how the forces feel, students working in groups explore two activities. One with springs, allowing them to see the numerical values of the force in newtons. The other, exploring similar scenarios but with stretchy cords. Students tried both activities.
I think that one would be easier.
Because you're applying more force at one end.
Yes.
Yeah, you're pulling it all right.
Because that's going to have a fixed amount, and then there's two people applying force to the opposite end. But that's just a suspicion. I'm not sure.
That's 5 then.
That's 5 for me.
Yeah, and that's 5 for me.
So if there's like an equal force, then that just like stays stationary then?
Yeah.
Because when you're like standing, you also have a force resisting you from the ground, pushing up as well as you going down.
Okay.
So I'm thinking it's a similar thing, but with the
Surely we need to.
Margin, yeah.
Do you reckon it's more?
I think so. So we found that this one was easier because there's more force being applied at one end, whereas on this one two people are struggling against each other and it's more cancelling each other out, so creating almost an equilibrium really.
Well, there's no horizontal movement. Yeah.
While they're doing that, I'm actually listening to what they're saying, but probably more importantly, how they're translating what they're doing into a mathematical picture. And then from that picture, being able to possibly address some misconceptions if those misconceptions arise.
And then we had here, like if it was just Sean and Travis pulling, they'd be exactly equal forces. And so, whereas with this one, I still think that our force is more than Sean's, but not.
But you might be pulling with B and you might be pulling with B, but in the direction of,
In direction of what this line would
in
be.
the direction of this line, yeah, perfect. There was one example where the students had 3 forces, so there was one in one direction, 2 in the opposite directions but at an angle, and they were saying that those 2 at the angle were double the one that was in the opposite direction, which was correct in terms of the magnitude, but in terms of the direction it wasn't. So we were able to use diagrams to kind of break that down, look at the components of the force. What's the force in this part of the direction? This way, coming towards me. Any ideas?
Well, I guess you've got to know this angle.
Okay, let's say, for sake of argument, the angle is 30 degrees.
Did you work out with trigonometry?
Yeah.
So if we were to take that situation, you'd have 2 lots of this to whatever Sean was pulling,
Okay.
or whatever angle. Is it going to be a greater force than it was if you're kind of standing at slight angles to each
Yeah, it
other?
would be because it's going the same way.
Yeah.
It's not being wasted going out sideways.
I like that idea of wasted. Let's see if we can talk about what that wastage is. They were thinking more deeply than maybe when I've done it in the past. Maybe when I first started teaching mechanics, I was looking at, well, this is what happens, and setting the scene, but showing them without them actually feeling it. And by feeling, they could see what's happening, and they were coming up with, oh, if I pull it at an angle, it's not quite as strong as if I pull it straight on. So we were able to address those ideas as part of it as well, which was probably a bonus, and I hadn't possibly anticipated some of those ideas coming up. If we take this one, you were saying about wasted force.
Yeah, it was going out sideways as well.
Because there's two, if the force is going at an angle, it's made up of horizontal and vertical. Well, two, one going along and one going up.
Yeah.
And if there's less going up, then there'll be more that force can do going along the other, like that, then there's that, and then there's that as well for each of them.